I'd like to take a look at absolute value. This really comes from lesson 2.2 of our Math and Focus textbook. Absolute value means the distance from 0. So if I think about a number line, I want to consider how far a number is from 0. It also reminds me that distance is always positive. And I'm sorry I have a combination of uppercase and lowercase here for some weird reason, but it is always positive. If you take a look at this first problem, what it shows is the absolute value of -4. That means how far is -4 from 0 on my number line. So I have a quick sketch of a number line started here, and oftentimes we'll put 0 in the middle to show that we are kind of separating our positives to the right from our negatives to the left. And if I want to move on my number line towards the right, I'm going to move towards positives, like 1, 2, 3, and 4. If I move backwards on my number line, I'm moving towards the negatives behind 0 or less than 0. And I'm going to see a -1, -2, -3, and -4. I really want to plot this point. -4 on the number line would be to the left of 0, right over here. And I want to think about how far away he is from 0, or his distance. So oftentimes we could count some jumps. I could start at -4 and count until I get to 0. 1, 2, 3, 4. The absolute value is 4. And again, distance is always positive. So I had to jump 4 units. Yes, I had to jump to the left to get to my negatives, but that's still 4 units away. Let's take a look at this next one. The absolute value of 7. Well, if I'm thinking of a number line, I could probably make my life a little bit faster. I know I need to only think about 0 and 7. And I could probably show the intervals in between if I wanted to think about jumps or steps. But 7 is the important point in this situation, and I want to think about how far away 7 is. If you actually have your intervals in here, you could probably count 1, 2, 3, 4, 5, 6, 7, and you would find that it takes 7 jumps or 7 intervals. That is really the same idea. I can show you just one quick arrow here and say, how far away is that? Notice the number value really looks the same. When I start with the absolute value of -4, I still get a 4 back. It's just positive. And when I start with the absolute value of 7, I still get a 7 back. The number value really looks similar. The only thing that might be different is it will always be positive as a result. Also notice, students like to keep absolute value bars on here. We don't want to do that. This is actually the math step that I've taken. This is the problem that I have to solve, and here's a solution. If you were to put it in absolute value bars, you'd have to go again, and again, and again. And you'd never really get to an answer. We don't want that for you. So remember, when we're done finding absolute value, the bars disappear. We've done the operation, we're done. If you move on in lesson 2.2, you're asked to do some comparison. And I really require students to SYW, show your work. So first thing I need to do is really ignore the fact that I need an inequality symbol, a less than or greater than or equal to sign at this point. I don't want to do yet. I want to decide what is the absolute value of -3. Well, how far away, or how many units, do I have to move away from 0? The answer is 3. How far away would I have to move to get to -5? Well, from 0 to -5, I could count them. 1 for -1, 2 for -2, 3 for -3, 4 for -4, 5 to get to -5. Looks like I'm just going to get 5. And again, it's going to be positive because we're talking about a distance. Distance is always positive. Notice I took those bars, those absolute value symbols are off, and I can really compare 3 to 5. Well, I know 3 is less than 5. I'll use a less than symbol. And if this is a true statement, that also means I can slide this inequality symbol into the original problem. The absolute value of -3 is definitely going to be less than the absolute value of -5. If you notice, the farther number wins. The farther number wins. Okay, so in this situation, we're looking for the farther number. Take a look at this next one. I have the absolute value of -650. There's no way I want to draw a number line and count the jumps, but I do know that the number value always looks the same. It would take me 650 jumps to get to -650. Now, how come I'm not making it negative? Remember that absolute value is talking about jumps or distance, and we can't run a negative mile. I can't run a negative kilometer. So instead, we keep this a positive distance, 650. We do the same thing for the absolute value of -480. We would say that is 480 units, intervals, or jumps away from 0. So we're really ready to do our comparing. Well, which number is greater? Let's ignore the original problem here. In fact, I'll try to cover it up for you. Is 650 greater than or less than 480? The answer would be greater than. 650 is greater than 480. So if this is a true statement and I'm keeping everything organized here, my problem from the left stays on the left and the portion on the right stays on the right, I also can slide this inequality symbol into the original problem and it will be true. That really means, who's the farther number? Oh yeah, negative 650 is definitely farther. The inequality symbol needs to face him. If we take a look at this last one, I gave you one with a positive in here because unfortunately sometimes we fall into a 6th grade trap. I see a lot of students say, oh, these symbols mean opposites. But do they? No. If I remember back a minute ago, we talked about absolute value is a distance from 0, and it really means it's always going to be a positive answer or result. So let's come back here and take a look. How far away is 100 from 0 on the number line? Hopefully you can visualize in your mind, this is that abstract thinking that we want you to get to. It is 100 units away, or intervals, or jumps. So I just write 100, and it's still positive because distance is always positive. Take a look at this next one. We would read this the absolute value of negative 200. Well, that must be 200 jumps. And yes, they're going to the left, but it still requires 200 moves to the left. That's a positive number because it's a distance. Let's do some comparing. And again, I might cover up the original problem and just compare my 100 to my 200. What would be true? Is 100 greater than or less than 200? It's less than. 100 is definitely less than. $100 is smaller than $200. Well, if that's true, and I kept everything organized, the portion on the left stays on the left, the portion on the right stays on the right, this will still be a true statement. The absolute value of 100 is less than the absolute value of negative 200. What I'm saying is the distance to 100 is smaller than the distance to negative 200, and it sure is.